Hello, I'm Martin Cottrell, General Sales Manager at Eclipse Magnetics for the Foreign Body Removal Department. Today I'm going to provide an overview of the use of magnetic separators in the food industry. Before we get started, I would just like to overview my industry experience. I started my working life at Eclipse Magnetics at the age of 18 years old. I've had the benefit of working in most sales areas of the business. However, I eventually settled in the Foreign Body Removal Department. In all, I have 26 years of magnetics experience, and I have around 20 years of experience working within the food industry. I had 2 terms of employment at Eclipse. These were split by a 4-year gap where I worked for a German manufacturer of metal detectors and X-ray inspection systems. Food manufacturers and ingredient suppliers should be making all reasonable precautions to ensure their product meets safety requirements. Quality systems are put in place to manage any potential risks. These quality systems are routinely audited, and where necessary, corrective actions are put in place. When we think about food safety, we can categorise 4 food safety hazards. Biological hazards, for example, Listeria, Salmonella and Campylobacter. Chemical hazards, for example, mycotoxins, natural toxins and food additives. Allergenic hazards, for example, nuts, fish and wheat allergies, and physical hazards, for example, glass, plastics and metal. Today's presentation is going to focus on metal hazards and the use of magnetic separators to remove ferrous and parametric stainless steel contamination from ingredients and finished products. We will briefly talk about different processing methods, selection criteria, different types of magnetic separators and installation areas. So, what is magnetic separation? Magnetic separation can be explained as the use of high-intensity magnets to effectively remove ferrous and paramagnetic contamination from liquids, powders and granulates. Paramagnetic contamination is stainless steel in the forms of fines or slithers that have been K-SAW work hardened. The K-SAW work hardening changes the structure of the material, and it can then be attracted to a high-strength permanent magnet. For example, rotary valves, slide gates and benzene pipes can all generate paramagnetic contamination. Magnetic separators are generally manufactured using material from the rare earth metals group. Magnetic separator manufacturers use neodymium ion boron, or to use its shorter but chemically correct description, NdFeB. These NdFeB magnets are manipulated in circuit design and produce exceptionally high magnetic forces. Typically, Eclipse construct magnetic separators with strengths between 7,000 and 12,000 Gauss. This measurement is taken on the outside of the stainless steel tube that encases the magnets, i.e. the product contact surface. In most circumstances, the units will operate up to 90 degrees C. There are some applications where this can be higher. For these, we change the magnet grades to achieve working temperatures of up to 140 degrees C, or actually up to 220 degrees C where it's required. Rare earth magnets are extremely stable and resist demagnetization extremely well. Handled correctly, the magnets can provide consistent performance for many years. Magnetic separators are ideally suited for use with powders, granulates and liquids, and some common product lines magnets are installed into are, for example, powders, flours, spice, starch, sweeteners. For granulates, grain, rice, seeds, sugar. For liquids, chocolate, sauces, jams, syrups, juices and etc. Magnets can also be used in the production of cereal, crisps, pasta, vegetables and dried fruit. There are some products which magnets can't be employed in, and these are generally dense or solid products such as meat, fish and cheese. Magnetic separators are commonly installed into gravity lines handling bulk materials, into lean or dilute phase conveying lines with typical line speeds of 20 to 25 meters per second, and pump liquid lines. For either of these processing methods, we need to consider the application criteria. This should be discussed or evaluated prior to any installation. We may ask you about the conveyed method, the flow rate, the bulk density, the product characteristics, the ease of access for inspection and cleaning, and any ATEX requirements. Eclipse categorised magnetic separators into 2 distinct types, primary and secondary. Primary magnets are used to protect against what we call tramp metal, for example nuts, bolts, screws, washers, generally larger pieces of contamination. Secondary, which are used to track small ferrous and parametric contamination from being present in finished products. Secondary magnets are more common as they are much easier to inspect and clean and can provide product and brand reputation. It is common to see primary magnets towards the beginning of a process and secondary magnets from mid-process and onwards, and even up to point of use or packing. In the examples of primary magnets shown below, you will notice that the magnet packs are large and usually work from outside of the process chute. This is because primary magnets are designed to offer large depths of field, and due to this, the magnet does not need to be positioned directly in the product flow. Primary magnets are mainly used for machine protection. The following examples are of secondary magnets. These units are always constructed from 1-inch diameter 316 stainless steel tubes which contain the magnets, and they are always sited inside of the process flow. Secondary magnets are designed to offer controlled magnetic fields of extremely high intensity. It is for this reason that these are best suited for the removal of fine ferrous contamination and usually employed for product protection. Magnetic separators are commonly installed in multiple locations throughout a process plant and can provide damage protection for critical machinery and at the same time protect the product purity. Installation of magnets throughout a process enables contamination to be removed at regular intervals. This can reduce possible damage to process machinery and act as an early warning of machinery failure or contaminated ingredients. In many applications, magnets are installed into process lines before value has been added to the product. This can be a great contributor in reducing waste and disposal costs. Metal detection and X-ray inspection systems are often detecting and rejecting product that has all the value added to it, and therefore any waste and disposal costs are in most circumstances going to be much higher. The next couple of slides will show a few typical application examples of magnetic separators. As mentioned earlier, magnets can be installed throughout the processing line, and when installed strategically, they can provide significant protection. Some typical installation points are raw material intakes, silo exits, rip and tip stations, pre and post critical machinery, for example industrial sieves and ball mills, before mixers or point of use. Some of these are classed as HACCP control points or even critical control points in many of our customer sites. The example shown below is an installation of magnetic separators into 10 bulk ingredient loading points. In this application, the end user would issue a clean magnet array to the tanker driver. The magnet would then be placed inside of its housing and then the tanker would discharge into the silo. After loading, the magnet would be inspected by the technical and quality teams. Multiple suppliers delivered the same product to this site, and the installation of magnetic separators on silo intake also meant they could do analysis on price versus quality. In this example, we show the use of a secondary magnet installed on the outlet of a keck sifter. The sifter was of a wedge wire basket design, and placement of the magnet post sifter provided product purity protection. A magnet was later added pre-sifter to provide machine protection. We have many installations just like this where the customers installed magnets pre and post. So that concludes the content for today. I hope you found it interesting, and should you have any further technical questions which arise from viewing this, please do not hesitate to contact me. Eclipse Magnetics can support you for all your magnetic separator and metal detection requirements. We provide annual site surveys or calibrations, and if you have a large project, we can provide a no obligation site-wide appraisal. So, after viewing this today, if you would like to get in touch, please feel free to contact me by any of the means shown on the screen. You also have the ability to download this webinar from the click down box, and you can also open a chat box should you want to start a remote dialogue. Thank you.